Hi, everyone. How you doing? My name is Johnny Vanderford, Lorain County Community College's MEMS and Microelectronics Manufacturing degree, which is Ohio's first baccalaureate level degree from a community college that is in electronic manufacturing. So we run a bachelor's degree, which is basically how to train people to do electronic manufacturing. You're currently in our lab right now, which we use to train people in. We have stencil printers, pick and place system, reflow, stencil print inspection, AOI system. And then most notably, what we're going to be talking about today is the system that's right behind me called BGA Rework. All right. So we offer a lot of hands-on training in this particular area, both for students who are part of the college, as well as private classes for anyone who's interested in doing this through our training institute called MERIT, which stands for Manufacturing Electronics and Rework Institute for Training. Blah, 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 sales pitches. So that being said, a huge thank you, a huge shout out to RBB for being one of our founding supporters, hiring our students, donating parts over to our labs. As a community college goes, our full-time students only pay $3,900 per year for all of their classes. So we really try to keep lab fees as low as possible. And Ross, Lily, Bill, McKeegan, Bruce, everyone's just been totally chipping in. We have, tape and reels of parts that we use to load up on the machines and everything. So a huge thank you. Thank you for being a founding supporter, hiring our students and making our degree relevant. All right. So let's talk about BGA Rework. All right. Let's do a live demonstration of what BGA Rework is. And let's talk about why companies hate it so much. There isn't a company around that I know that likes to do BGA Rework, because the moment that you have to do BGA Rework on something, that means something's wrong. That means that something is broken or it's not been soldered in the correct way. That means there is something incorrect. This is, typically speaking, something that adds cost to whatever the product is that you're working on, and is usually based on something that is preventable in some way, shape, and form. So for BGA Rework, I want to get into a little bit about what it is, why it is what it is, and how to do what it is. Okay, so BGA Rework is, in a nutshell, lower down my camera here, BGA Rework is nothing more than a hot air rework station regarding all the things that it can potentially do. So if you're not familiar with hot air rework stations are, well, actually, if you're not familiar with hot air, let's show you one. So hot air rework stations consist of a tool that looks something kind of like this guy does right here. This is our quick 861 DW hot air rework station that has settings for temperature and airflow out of a pen that the operator holds in their hand that blows hot air out of the tip of this. And you can buy different size tips for being able to blow hot air out of this. And what this tool is used to typically do is the tool is typically used to heat up an already soldered joint to the point where that solder joint goes back and reflows, goes into its liquid form. So you can take a chip off, put the chip down, and ultimately reattach it to the thing that it needs to be attached to. This machine, this BGA Rework tool, is essentially the same exact thing, the same exact tool, but with a couple of bits of more precisions and automations associated with it. So the tool that I'm displaying in front of you right now is a Mancorp RW1210 is what this is. These tools go for about $15,000 per tool, $15,000 to $20,000 per tool, with $15,000 for the bare bones, $20,000 with lots and lots of accessories, which I'm going to show you a couple of. I'm going to show you some that are useful and some that are just like, bleh, right? Let's start out though with the primary functions of the tool. All right. So this tool has 3 heated zones on it. The heated zone number 1 is this spot that's down over here. This little piece that's down over here, which I can raise up and down using a tool to it there. Hopefully I can zoom in. We can kind of see that there. So I can move this tool up and down. This right here is a hot air blower that blows out through the top of it. And actually, this piece that's on the top of it right now is actually what we would call a confining tool. This is something that you need to have for your hot air rework station, because right now there's this thing that's here and it's blowing air out in kind of a more or less a conical way. It's just going to blow it out all over the place. When you're doing BGA rework or hot air rework in general, you usually don't want to completely overheat the entire board to the point where all of the solder joints are reflowing all at one time. You kind of want to focus it down to just the one component that you've got to get that to rework all at one time. So that being said, you use these confiners that are on here, both on the bottom as well as on the top part of the tool. So on the top part of it here, I have another hot air blower that's blowing out past this little tool right here, and I can confine it using this magnetic coupler or magnetic part that fits on the top part of it there. Now, the other thing that's on the top part of this tool is a vacuum tip nozzle, all right? And the vacuum tip nozzle has a little piece of metal that, I don't know if you can see that on the screen to it right there. This little piece of metal is what holds the chip into place using a small piece of, or a small vacuum pump. The infrared heating block is typically used to kind of preheat the entire board to the point where it's not going to be thermally shocked. And then the main blowers come in to reflow just the part that you're looking to get reworked in that process. BGA rework is one of those things that's really, really kind of hard to justify as a repair company, if it's even valuable at all. But as a manufacturing goes, I mean, we can all say, if manufacturers, we can all say, there has occasionally been a tray that has been put into the machine in the wrong orientation. We can say that we've received parts every once in a while where the parts are rotated incorrectly. We can say that we've put the wrong part down by accident and it wasn't caught by any of the technicians or the machines or anything like that. It was caught at AOY, and all of a sudden we realize, oh no, we have 20 boards that one BGA chip, which is usually the most critical chip on the overall board, right? BGAs, ball grid array chips, means that it's a processor, it's a graphics chip, it's some memory, it's a higher functioning part of the board, and usually a more expensive part of the board that has to be a part of the board's function in order to make the whole thing work. So that being said, it's usually kind of a critical piece of the board, which also makes it really, really expensive to process with it, you know? And so for ball grid array rework, that cost of the part, how you source the part, how you get the part, all factors into whether or not the thing is even worth it to do in the first place. And I've seen repair people that use just infrared heat to do the overall process. I don't recommend it. I very much don't, because you need the infrared block to kind of preheat the board up to a general temperature. But most of the work is all done using the top and bottom nozzles to this. To which case, this nozzle that's up over here, this vacuum tip nozzle can take and I'm doing this bare hands right now. I'm going to put on some gloves in just a little bit. I've got in my hands, in the camera here, a little BGA rework chip, and using a button that says manual vacuum on the front part of my touch screen here, I can take this chip and attach it to the top part of it here, and it's holding it into place using vacuum to it. So this chip is being held into place using just vacuum by itself, all right? Now, on top of that, though, this is one of those things to where you get different nozzles with this machine. You get like different size nozzles, because you may have a smaller BGA chip like the one that I've got here that has 84 pins on it, or you might have something that's like literally hundreds and hundreds of pins, and you might need something that's a bigger chip that has more area to hold the chip down with vacuum with it, all right? So you might have kind of any one of those with it here. I'm going to turn off the vacuum for a second so I can put back on the confiner and demonstrate something else that's with this. So this whole part at the top, this whole vacuum nozzle at the top can move in a vertical orientation up and down. I use this joystick that I've got here that is on the left-hand side of the machine that says up and down. And by moving that joystick up and down, I can raise and lower the head of the top heating nozzle. So the top heating nozzle has, I would say, about a foot worth of translation that it can do in conjunction with about another few inches of the bottom nozzle, which I can use this knob on the side to just mechanically move it into and out of place. One of the things that you may notice on the bottom nozzle, is that there's a small screw in the center. This screw is used to provide additional support to a circuit board if it's a large enough board to where it's kind of sagging in the middle of it, right? Some circuit boards we're fortunate to have some circuit boards that are more or less rectangular in their overall shape. But that's not the case with every single circuit boards. As we all know, customers can design circuit boards to fit the need of their product, and they can be round, all sorts of different shapes with it. So that being said, what you sometimes have to do with certain circuit boards is you have to mount it in such a way to where you can't use the railing system that goes with this. So this machine has some rails that are with this here. And you can see that I'm sliding one of the rails back and forth on here. Another one of the rails, I'll unlock it here. I can slide this whole thing kind of in and out of place. And what I can do is, I'm gonna lock this rail into place here. I can load this board in to this part of it here and more or less kind of tighten that into place. And that keeps my board housed to it right there. I've got a nice rectangular board, which makes that easy to do. So if it's a depanelized board, hey, you're in luck, piece of crumb cake. If it's not a depanelized board, you have to start asking yourself, do I have any holes to work with? Do I have any mounting holes of any sort to be able to work with it? If it doesn't fit into the rails, what you can use is a little accessory that's on here, which is these little parts that are right here. So you can move these parts out of where the rails are, and these little pieces have places to where they can kind of hold on to the board. I've got one in a hole right there. I'll put another one into a hole right back over there, if I even can. Well, I might not be able to for this one. It's a big board. It's a big board. It's a big rectangular board is what it is. There we go. And if I have two more that are in the back that can more or less hold this thing flat into place. But if I have a board that's kind of got an odd shape, I have the ability to use these little pins that are on there to fit inside the mounting holes to see if I can get it to hold it into place, if I need to be able to do that. For what we're going to demonstrate today, we actually won't need these guys here. We're just going to use the rails to make things nice and easy for that. So, and again, stop me if you have any questions or anything like that as well. So other features that the Rework station uses in order to get it to work the way that it does. Actually, let's do this here. Let's mount the board into place here. All right, and tighten this down. All right, so on the board itself is a couple of lights, or on the machine is a couple of lights to it here. So I've got the ability to turn on and off some lights, but I also have a little laser that's right here that points down at approximately where this board happens to be. So I'm actually going to demonstrate this first using a QFN chip so that you can see kind of what this looks like, which actually, now that I'm thinking about it, I'm going to need a QFN chip in order to do this correctly. So where do we go to get our QFN chip? Let's go inside of our dry box and grab one of our little QFN chips out of here. Oh, here we go. And I'm ESD grounded right now with ESD shoes at this point. So I've got some ESD things that I'm wearing to it on there. But normally speaking, one of the things that I very much so recommend for doing BGA Rework is a pair of these ESD gloves that we wear that are cloth and partially thermally shielded as well. So let me open up my JEDEC tray, take out with a pair of tweezers one of the QFN chips, QFP chips, sorry, not QFN. It's actually a QFP chip. That makes it even more fun. So here you can see on the screen here, I've got around a, oh my gosh, it's probably like a 64-pin QFP chip is what we got. What I'm going to do with this chip is I'm going to place it down over here. And let's load it up onto the machine here. I'm going to turn the lights on. And actually, let's load this up onto the machine. Let's turn on the manual vacuum so that we can take this chip and put it up onto this part of it here. Okay, so that's being held in place using the manual vacuum. Make sure that My camera is all correct here. And now, so one of the things I'm going to show you next is the camera. So this whole thing, this whole machine, this is the primary reason why people buy this machine, is this camera that's actually housed in the back part of it here. So there's a camera that pulls out, and what you are now looking at on the screen as of right now, you can see that, you are now looking at an overlay of both the top of where the part is housed and the bottom of the board. So let me use a light adjustment and zoom in. And now, as of right now, you should be able to see the board. So these are the pads that are going around the entire board where this QFP chip would eventually go. All right. Now I'm going to turn those lights down and turn on the top light. So the camera is now displaying and looking up at the actual part that I've put down. And I'm going to straighten this out a little bit using my fingers first, just to give it kind of a large gross alignment. And then bring this into focus by lowering this down. And you see how now I've got a chip that's on here. Do you see that? Do you see that, folks? I'm just making sure that that's visible on there. Yes, no, yes, yes, hopefully. I hope so. Carrie, can you see that? Is that easy to be able to see? Cool. Okay. All right. So here's the general process and the kind of the fun part about how this machine works. The chip is connected to the top nozzle. On the right-hand side of the BGA system is a micrometer that I've got my fingers on right now. The micrometer, when I rotate this micrometer, will move the chip in small increments of polar theta. I can see actually one of my pins is actually damaged on this chip from how I grabbed it out of the chip component to it there. Got to be careful when you're handling the chips, right? So this pin is actually sticking, this pin is actually bent, but by rotating the micrometer, I can rotate my chip in a polar theta coordinates, right? In addition to that, closer to the stage are two additional micrometers here and here. These will translate the board in X and Y. So now I'm going to move the board around in X and Y. You can see this is kind of a game of connect the dots, if you will. You know, you got to kind of, well, not with a QFP, it's more with a BGA. You'll see that the dots have to be more or less connected. So we move the board into its place. We rotate the QFP part until it's about in the right place there. And we can see now that we zoom into this, that the chip, as well as the board, with the one pin exception to it right there, are more or less aligned. You repeated what I said, Nate. Thank you. All right. So yeah, the students that are here are saying, hey, the pins are broken and bent. That's with it on here. Yeah. So this is from me grabbing it with my hands is the way to phrase with that there. Yeah. Yeah. So we've got a chip. Now, this is one of those times to where an operator on a manual system like this, and this is kind of a semi-automatic system. There are automated versions of this system that can work, and I've seen them up around the 80,000 plus range for just one of the machines to it there. More or less, this is where a lot of the operator training comes in handling the chip and getting a manual alignment of the chip into place. All right, this takes time to do. When we train on people doing this in Merit, we tell them spend some time doing this. Check your polarity markers, right? More than half the time, when people have to do some sort of a BGA rework, it's because the chip was put down in the incorrect polarity by the pick and place system or by some sort of means with it on there, right? The problem is with that is that you have a second chance to be able to do this, maybe, you know? You may not get a third chance out of it. Technical data sheets usually specify how many times a part can be reflowed or at least brought up to a reflow temperature. And for many parts, it's not an infinite amount of times, all right? Some parts, it's literally only like maybe 2 or 3 times that part can reach an elevated temperature before there's just other things that are gonna happen that the companies won't guarantee that the chip will function afterwards, right? So this is something that people have to be aware of, that you've got one extra chance to be able to get this and get it done right, right? On top of that, doing BGA rework is in many ways somewhat of a slow process to do. It is a very, very slow process, because what you have to do is, if you want to attach this component down to this board, you've got to reflow it again using all of the similar reflow settings that you had with additional solder paste. And that's one of the things that we're going to do with this chip here, even though it's a little bit bent. That's on the one lead to it there, but we'll still work with that anyway. So, all right. So any questions so far? Any questions at all? Questions for you two? No? No? Makes sense so far, everyone? So let's talk about our friend, Flux. Fluxing agent is your big friend in doing BGA rework. Generally in surface mount technology, Flux is a big friend for being able to do this. Flux provides a better solder joint when activated. It cleans and decontaminates the surface of any potential contaminants that will make soldering just not happen or just make it worse, is what it is. So after you get the alignment done on the screen, so our alignment is considered to be at this screen right now good enough. So we're actually going to move the camera out of the way. And now onto our board, we're going to kind of come in here, and I'm going to take some fluxing agent and attach some flux all along with the pads to it here. And I'm using a dispensing tool to dispense Amtech TC559 Tacky Flux. I prefer to use Tacky Flux just because I like the way that this one cleans, actually. That's my favorite part about this. This one cleans up very well and has like long-term multiple use when doing rework and repairs on parts. All right, now I'm going to use the joystick, and I'm going to lower the part down all the way down till we get down to the board, and then come down onto the board right there. And I see that it's touching the board at this point. So now what we're going to do is make sure that my bottom nozzle is raised up to where the board is, and I'm going to start the rework process. Now, I don't know how well you'll be able to see this screen here. Normally I zoom in on videos to be able to see this, but I've got a small control panel that's down here that more or less is what I use to program how the rework happens. Actually, let me show you what a program looks like here. Let me put in my super secret password. Is that it there? Okay. Okay, so what you are looking at right now, if you can see this here, is a program. The programming for this is similar to programming a reflow oven, with the exception that there are ramp rates and the amount of time that you want to hold at a particular temperature. So, for instance, this profile has 4 segments, 1, 2, 3, and 4, going all the way across. The top and the bottom temperature are the same throughout each one of these, where, for instance, in segment 1, I have the temperature set to 160 degrees C with a top time. The time it takes to hold at that temperature is 30 seconds and a ramp rate of 3 degrees C per second, which for many rework people, I've been told that 2 to 3 degrees C per second is sort of the standard BGA rework temperature that it takes to work on. Bottom temperature, same thing. And so my times going along the way here, my first segment is 160 degrees C for 30 seconds, 190 degrees C for 30 seconds, 220 degrees C for 30 seconds, then 250 degrees C for 40 seconds. Something maybe to make a note of, we're using lead-free solder. So we're using standard SAC 305 base solder. It's rule of thumb kind of recommended that you never take a board or a chip over 260 degrees C throughout any point in time in a rework or reflow process. So we're going to keep it there. And if you do go over like 260 degrees C, that it only goes over for a maximum of 10 seconds. That's kind of considered to be like your general, like your rule of thumb. It's different for every solder paste that's out there. Everything is a little bit different with it, you know, which speaking of, well, we'll get into this here in a little bit. So the other thing that's on here is the IR block that's down below here. Its temperature is set to 200 degrees C. Now that's radiative heat. So that is not the actual temperature that the board is getting to. That's just like the general heat zone of the black part of the block with it on there, right? So we have the ability to program all of that, as well as a cooling time, like how long it takes for it to cool while it's on there, which we have just set for 120 seconds. So you think about it, if you think about it, So this is 30 seconds, 30 seconds, 30 seconds, and 40 seconds. That's 130 seconds plus a couple of minutes worth of cooldown time. So you got about 250 seconds of processing, not to mention the ramp rate set in that it probably adds another like 50, 60 seconds or so. You're talking about a 5-minute process for a board. That's not that different from a reflow oven in a lot of ways with that, right? So let's start this process. Let me go back to regular operator mode. We're currently set to be able to start the process. I'm going to come over here, hit the green button for starting this process. And what's going to happen here is 3 of my 4 thermocouples are going to start sensing temperature. There is a 4th temperature sensor, which I don't have connected up as of right now. More often than not, one of the biggest concerns when doing rework is to make sure that your board does not go over a particular temperature. Just because you are setting the temperature of these hot zones here, I'm going to put on some gloves just because I've got some hot parts to it now. Just because the top nozzle is currently at 130, 135 degrees C, doesn't mean that the rest of the board is at that temperature as well, right? So I've actually got at this point here to a little bit of a question of, well, what temperature is my board at? In the early phases of figuring out how to do BGA rework, you kind of need to use Kapton tape and the thermocouple wire to tape it down to the board, tape it down to the chip to see what its actual temperature is. Once that's established, though, you kind of just don't have to do that. You don't have to do that each and every single time to it. Although for quality and production reasons, you may just want to guarantee, yes, that chip did get up to that temperature in order to get that done. So it's not a hard thing to be able to do with it, and it's something to be able to do with it. Another difference between rework and repair. Rework, when we use lead-free solder, we're stuck with that. We have to use lead-free solder to do all of our processing. Repair people, they don't care about lead-free at all. They want to use lead every single time because, let's face it, lead's easier to work with as a solder joint. So it's easier to process, it's easy to work with. And so the repair people try to get away with just using lead. So all the third-party people, unless there's something I don't know of, they're all using lead just because it's more simple to do. All right. You can see on our thermal profile here that our top and bottom zones are currently ramping up to the 3rd segment. So we're about a little bit more than halfway through the reflow profile for being able to do this. Once this actually gets into its 4th zone, its 4th segment, what I'm actually going to do is kill the vacuum at the top nozzle. Notice, by the way, also notice one of the other things that you will want to have with a rework station, fume extraction. Make sure that you've got fume extraction somewhere in there, because if you're using fluxes or anything like that, you're using any kind of lead-based solder, you want to make sure that all the fumes are being extracted out. So that's what this black hose is kind of here for, is to do kind of a fume extraction for this. So we're ramping into the 4th segment as of right now. One of the things I'm going to do is I am going to cut the manual vacuum and lift up ever so slightly on the BGA Rework tool. So that's still blowing hot air on the whole thing. That's still blowing hot air on that chip and everything. I'm willing to bet this chip does not actually, because one of the pins is bent. So this is probably not just going to, this might be a little bit ugly in terms of what it looks like there, but we'll see. We'll see with that. So at this point, I can see some fumes that are being extracted from the flux. That beep indicates that the process is done, that we have reached the temperatures, and now cool down is beginning to occur. I'm going to lower down my bottom nozzle. At this point, the part is more or less attached down to the component. We're going to take a look at it here in the next couple of minutes on the stereo microscope to see if everything looks like it's all soldered up and aligned. That's usually one of the things that you have to do after a rework process has been completed. Station, which has got a soldering iron, some solder, and a stereo microscope to it. So yes, usually before you do any kind of and actually in reality, that chip may not be soldered on. It might just be using the tin that's on there to be able to do this. Yes, you're absolutely right. So normally what you have to do is you find the pads where you look for, right here. There we go. There's our pads to it. See them there? And these pads have to be tinned before any of the rework occurs with this. So you'll need some flux, some solder, and a soldering iron. Now there's one of two tools that you can use for this. I'm going to put some flux down first. I think this one actually might have, oh, this one might be the board that has the tin solder joints on it there, which is okay. It's okay. We'll use this more of a demonstration piece is what this is. So I've got a tool that is useful for being able to work with this, and that's a solder spatula is what this is. This tool, which let me hold this closer to the camera here. This tool is basically a soldering iron tip that more or less has a wedge at the tip of it rather than an actual soldering iron tip. So when I put this underneath the camera view, kind of what you see, the spatula, and I'm going to apply some lead-free solder to kind of both sides of the spatula. And then what I'm going to do is I'm actually going to run the spatula gently across all of the pads, which is actually going to tin all the pads at one time. And I'm using kind of gentle pressure to be able to do this, letting the flux do what its job is as well at putting some tin on the all the sides of the pads. This sort of has to be done in advance before any rework is really kind of possible for one of two reasons. One, I mean, if you're working with a bare board, well, you need solder to solder. Like that's a flat out simple case with it right there. Two, the other thing that you need if you are doing a rework job is you need to lift the chip off, clean up the pads once they are done, and then those cleaned up pads need to have solder reapplied to them and have it cleaned off before it goes on again. Now I'm using tacky flux. So technically speaking, this flux, like based on just doing repair work, everything like that, like this flux is good to be used kind of over and over again, but you can't just leave it on there after a while. So it does need to be cleaned up. It eventually could be cleaned up with something like isopropyl alcohol. So I've got, for instance, a container here which has some isopropyl alcohol on there, and you can see that IPA actually does a very good job of cleaning up these particular pads. And this is a demo board is what this is. So you can see, well, one of those pads, some of those pads that are right there at the right-hand side, those are bridged. This is what those are. Those two, I don't know if you can see those two right there. Those two are bridged over together. So I probably want to run the iron across those one more time. But let's try kind of a little bit of a different process with this here. Let's actually do a BGA rework process using an actual BGA rework chip. All right. So I've got a board here in my hand that's got a single chip attached to it. If you can see that on there, right? You see that there? Let's just say that I want to take this chip that I've got on here and remove it from this board. I want to take this chip off. And this is an 84-pin BGA chip. Step one, what I'm going to do is apply fluxing agent kind of around the outside edges. And flux is cheap, so just use it. I use it kind of sparingly with this here. Doesn't really matter all too much with it here. I know repair people actually use it quite a bit more than I do with it. So there's all the flux that goes onto the chip. Right now we come over to the BGA Rework station here. We'll take a look at this board here in just a little bit, if that chip is even attached to it at all, right? Let's load on the next board here, one of our training boards that we use. Kind of slide this into place. There we go. And we're going to align up the laser dot that's on the system there with where that component is. Can you see that? Nate, can you see that? A little laser dot on there. See that there? There it is. And let's get a better view of what that looks like through our optical camera. So I move the camera system out. What you're looking at is the top nozzle right now. And right there is the bottom of the board. That's what the actual component is going to be with it. And that allows us, if we were to overlay both the top image over the bottom, that is going to be about where it picks this up. So we'll make a small adjustment for this. Now for lifting the component, a lot of people use a special insert, which, to think of it, I had one sitting here and it's not here anymore. Where did I put it? little red piece. Where did I put my little insert? So there is an insert that actually goes on the top part of, or on the bottom part of the nozzle. Hang on one second, folks. There we go. I got a bag of them over here. There we go. So I've got these little silicone inserts is what these are. These are inserts that actually go on top of the, or connect up to the rework tool that I've got here. So for instance, here, whoops, grab the wrong size. Just spill a bunch of them out so I can get the right one. There we go. I'm going to take the insert off by unscrewing it. Take a little silicone piece, plug that in. And so now my vacuum tip insert has a little silicone piece. This is very useful for taking chips off. This is very not useful for being able to put chips back on because you need kind of some precision placement for it. So it's really only something that you use to take a chip off of here. So I'm aligned up at this point. So if I look back at my camera system here, I can see that I've got some alignment with this. All right. I'm going to put my confiner back on the BGA part to it, or back onto the on the liftoff tool there. And now what I'm going to do is come down all the way down to the BGA Rework chip, all the way down so that I am on with a manual vacuum going, go down until I make a contact with it and lift up ever so slightly. Now I start this process again, where I've got both a bottom nozzle as well as a top nozzle that's providing hot air on both the top and the bottom, as well as the infrared block that's ramping up to about 200 degrees C in this process to it. While this works, how many of you have heard the term reballing before? You have to question at some point, can I use the same chip again? For instance, if you are taking a chip off of a board, right, because it's in the wrong orientation, right, you have to at some point say to yourself, can I just reuse that chip, right? That may be an inventory question. That may be a customer specification question. That may be a data sheet question based on the chip, but that's usually a question that comes up. When it comes to doing rework on a manufacturing site, there's generally speaking a better chance for there to be some excess parts, excess chips available to be able to do this with. And it depends on the type of part that it happens to be as well. But that's not always the case for repair people. Repair people, on the other hand, don't often get the chance to be able to see or don't be able to get an extra stock of all of the chips that they've got. They usually have donor boards. They have boards that were working, refurbished, or just taken apart that are not currently working in a working state. And they take chips off of those boards and they put them back down onto the new board. Will it work? Maybe, but it's that's one of those things. Repair is just one of those. Just get it working. Just make that screen come on so they can take their data off and buy a new computer. Along those lines with it there, right? Looking at our rework process here, I'll show you reballing here once we start to cool down. So our rework process that's occurring, we're currently ramping up to the 4th segment. I can see some fumes coming from the chip to it there. So I'm actually going to kind of pull up ever so slightly with the joystick. Oh, it's still attached to it as of right now. So we're going to let it sit there for just a little bit longer. There we go. The chip has become attached or detached. I have desoldered the chip from its current position. I'm going to use the joystick to raise it all the way back up. You might hear a beep sound in the next 10 seconds-ish or so. And so this chip has now been removed from this board, all right? And I'm going to use a little tray for this part that's over here to turn off the manual vacuum, and it's dropped the chip down into its place to it over here. All right. Oh, so one of the students just asked, why did it start beeping once it's done? That tells you that it's at its end of its cycle. So the beep is literally an end of cycle type of thing. And that's one of those, do you see how long this is taking, Nate, to do? Like each time I run this, it's like a 5-6 minute kind of process just to run the rework process. You know what happens to people when they sit still for a few minutes too long? I start getting distracted and looking at other things, right? We can all say that, right? We can all say that we, had a process. Okay, I've got some few minutes. Like I've done that before a million times. Bake a bag in the popcorn, bake a bag of popcorn in the microwave, set it for popcorn, walk away. It's done. The beep tells me that it's done at that point. It's a good. Right, yep. So here on my microscope, I can see that I have removed a BGA chip, a bad BGA chip from here. And then on the actual board itself, which I'm going to slide off of the BGA Rework tool. There we go. Oops, had that fall down there. There we go. And we can see that chip, which got removed from this position here. All right. So and I'm looking at this board. And that looks kind of messy, right? I've got some solder on some of the pads. I've got some completely bare and empty pads with it on there. I've got a BGA chip that's got some balls that are on the chip itself and some pads that just don't have anything on there. So this is where we ask one of two questions. Question one is, can I fix this chip up and just put it back on there again? Or do I go and grab a new one and just say, let's fix up the board. Let's not worry about having to do too much rework over and over again. Let's put a guaranteed new chip down onto the board if it's available, right? This is a stock question. This is one of those things to where, like, did I get extra stock of components to be able to put down onto the board? In some companies' cases, you got 100 components. You had to make 100 boards. Your customer was mean and didn't give you anything extra, That's it. That happens from time to time. And if that's the case, now you're in the land and world of reballing at that point, because you kind of don't have an option to that. Now, reballing itself is a little bit of an art form more than anything. Generally speaking, you buy a fixture that looks something kind of like this, which is used to hold a chip into its place. There's a little screw terminal that's on here that widens and separates down, and you take a chip to be reworked, such as I've got a CPU that's right over here. You have a chip that's to be reworked, and you take this chip and you more or less tighten it into place into the clamps on this thing. And I need to potentially, it's a little bit harder to do when I'm holding the whole thing to it here. So I might actually, there, I think it just fell into place there. Let me see. There's one side of the clamp on the TV there. Oh, doing it the wrong way. Okay, so now I've got a chip that's more or less there, but you can see that this chip is in no good of a shape to it, right? See what that all looks like there. So if I'm going to reball this chip, a couple of things have to occur all at one time. Number one, I have to remove all of the solder that's actually on this actual chip here, which that's actually the easier process to do. I'll demonstrate this here. I apply some flux, like what I got here. Use a whole bunch of it right there. You see that? I take my solder spatula, the little spatula that's got all of the flat parts to it there. I'm gonna zoom into it right here. And then very slowly and carefully, I make my way across all of the pads, as you see here. And I use what I can only call gentle pressure is what I'm using for this. I am not squeezing this too horribly hard to be able to do this particular process. I'm more or less just running the spatula while applying a very light pressure on top of the whole thing. And again, flux is your friend. I did not apply flux to this entire thing. This is damn near impossible without flux to be able to be used with it. It's just one of those things to where you're going to have to use some sort of a fluxing agent to go along in order to be able to do this here. All right. But you can actually, one of the things I want you to see is if I kind of hold this up here, let me raise my microscope up just a little bit here. If I hold this chip at an angle, you can see the height of all the solder, all the bad solder that's in the middle versus the height of all the rest of the pads that are on this, that are on the interposer of the BGA chip. Do you all see all of those? So I'm more or less making this for the most part flat. Oh, geez, look at that. There's Epcot Center right there over in Disneyland. Jeez. All right. So I'm more or less just trying to make this overall part. Oops, my light has come a little bit loose. There we go. I'm more or less trying to just make this flat going all the way across the entire thing. So that's what this first part of the process is. So the first part of the process is to remove and clean up all of the solder that is on the pads of the chip, right? This takes someone with some hand dexterity to be able to do, or actually a really cool company that I've seen that makes a more semi-automatic version of what I'm doing is FineTech, which is a German company that makes a tool that it has the ability to more or less semi-automatically and programmatically run a spatula across the entire chip. So now the entire chip is, from an operator standpoint, more or less flat. It's probably not perfect just because I'm not entirely a machine. At least that's every time I try to click on one of those things that's, are you a robot? You know, that's always a question that pops up when I'm trying to log on to various websites. So you clean this up, clean up the chip that's on here with some IPA and a wipe, right? So I've got a little IPA, a wipe. I'm gonna mount this back into my fixture here. And now what you have to do is you need to load up a BGA Rework stencil. Now, let me show you what that looks like once I got the chip mounted back into place. Okay, so here, let me take a step back here for a second. So that's the chip that's mounted into this clamping tool. It comes with a mated little frame that you can attach a stencil into, that when these two are placed on top of each other in this particular way right there, these guys more or less just sandwich each other on top of each other, just like that. Oh, something just fell out. What was that? Oh, the alignment tool, of course. That would fall out like there. All right, so can you all kind of see what that looks like there? And like, so if I put this underneath the microscope here, what you more or less have to do with this tool, if I've got it in the correct place to it here, is you put this over the places where the pads are going to be, which in this case right here, do I have it in the correct orientation? I may not have this in I may not have this entirely in the exact orientation to either that or my alignment tool just came loose to it. But anyway, so what you do is you make these little stencils. You make these little things that I've got in my hand right there. This is the same as any type of stencil that you would use to print solder paste on, except it's got a couple of extra holes in it that are meant to mount inside of this guy that's right there. And for whatever reason, I have lost my alignment on the particular one that I've got here. Do I have my tool for being able to do this? I did at one point here. I did have a little Allen key. Oh, I heard it just now. So what you do is you put one of these stencils in here by, let's see, unloosen the screw, loosen the screw, loosen the screw, loosen the screw. There we go. And this more or less, that somewhat loose in there. There we go. Somewhat loose, kind of loose. Might be also that my chip, oh, that's what it is. My chip is loose inside here because my clamp screw came loose. Of all the things to happen, right? Of all the things to happen, right? It only happens when things are live. Actually, it's not happening very well at all with that because this one doesn't appear to be, well, okay, so anyway here, hang on 1 second here. My clamp is not agreeing with me as of right now. And this is part of why reballing is a little bit of an art form, is because it has to be done for the most part in a somewhat manual process. So there's two ways to do reballing. The first way to do reballing is kind of the way that I'm doing it right now, where you have a stencil that this stencil more or less fits on top of where all of the interposing balls are. There they are. And so what you do is where those balls happen to be, and I'm not entirely in the exact center. There we go. just about there. Oof, there, right about there, right? So you have two options at this point. Option number one, put solder paste through all the open apertures and then use a hot air gun to heat it up to where the solder paste will sink down onto where the balls are. This process sometimes takes a little bit of some time to be able to do. Option two is to actually use solder balls. You can buy solder balls in themselves and actually allow them to kind of fall into each one of these spots here. That guarantees you a little bit better of a volume, but you have to have someone that can basically sprinkle solder balls into all of these open locations to it here, right? So reballing takes some time, it takes some effort, it takes, and for repair people, ultimately in the end, this is actually somewhat of a difficult process to be able to do, for being able to do this. Now, rework people who are in the manufacturing side of the fence, they have the opportunity, a better opportunity in many cases, to get extra parts. So let's head over to our dry box real quick, grab another BGA chip. There we go here. Now, where are my BGA chips? There we go. I've got a tiny piece of a JEDEC tray. It's one of those, again, we look for donated parts as often as possible. And so here I've got my miniature, it's not even a full JEDEC tray. It's like, you ever seen one of these before? Look at that. That's quality, is what that is right there, right? And sometimes that is what you get though. Ultimately, that kind of is every once in a while what you get with this, right? So let me open up this guy here, open up this guy here, peel this guy back. There we go. I got one that just popped out to it there. Perfect. All right. So now I have got a chip now that has a fresh set of balls on top of it there. So this one's already been, this has come in terms of how the manufacturer has decided to make this. All right. So let's find our board that we need to rework here. Here is our board right here, right? That's the battery clip. Where is my rework section? Where is my rework section? Oh, there it is, right there, right? So fit it all on one screen. Here is my pads to be reworked. Okay, we're going to take some fluxing agent, move it across all of the balls or all the pads to it here. Use my solder spatula once it gets up to temperature. These things are usually just a little bit bigger in terms of what they overall how long it takes for them to get up to temperature. Gently drag this across all of the pads. And I'm going to make sure that all of my pads have some sort of solder on them. Kind of taking some time to be able to make sure that they are all tinned over, that they are all of a similar flatness to it. There we go. It's more like I want them all to be just about the same height. And so if I can get it to be flat, that works. But with some of them, you can just visually see that in some of the cases, there just isn't solder on some of the pads. So the flatter it is, the better it's going to be with it. But usually at the end, that does, when you're doing it in this way, there is a little bit of some non-flatness to it. There's some concavity to the pads when you're doing it this way. And it's one of those things to where it's kind of a hard thing to be able to avoid in some of the cases. You almost like really just can't get it flat for the most part with it. It's one of those things to where you could try, you could try with it, but the success for it, I think, is somewhat operator dependent is what it is. Another one of those operator dependencies. All right. So now I've got my BGA pad back in there again. I've got a little piece of solder that's sticking up to it there. And I'm going to remove the silicone tip from the BGA rework hole because it's not going to help me. It's not going to help me to have the BGA able to shift around with a little bit of some rubber to it. I want that thing locked into place. So I want just the metal tip on my BGA rework tool. All right, so now let's get the correct orientation of the part, which I see on here right now. And what we're going to do after we attach this part is see how well we have attached this part. Oh, there we go. So I've got that held into place. I bring my camera out so that I am now looking at the actual screen here. I'm going to turn my top light down so I can focus in on my board. There we go. So there's my board. That's what my target is going to be for being able to do this. Now I'm going to turn up my top view here. And this is my BGA chip that I want to attach. Now I play connect the dots. Which is, I love being able to say that because that's literally what this is. Like BGA Rework in a nutshell is a very stressful connect the dots in some of the cases to it. All right, so here we go. All the dots appear to be connected. I'm going to zoom in just a little bit just to get a better view. Some BGA Rework tools have the ability to look at just the corners and keep those in focus while you zoom in. We do not have one of those tools. I believe that's kind of an expensive attachment that we just chose not to get just to teach the regular, just to be able to teach how to do BGA Rework in a on standard components. But for large components, like if you've got chips that are 500 plus 700 plus pins that need to be BGA reworked, you might need to have one of those attachments to it. Okay, so now let's apply some flux down to the board. So I've got generous amount of flux all over the place here. We're going to lower our component down all the way down until it touches the board. And there we go. Raise up my bottom nozzle as well. And let's start the next and probably potentially last of the rework processes that we're going to be doing on a demonstration. Because the other thing that you honestly need for this process to truly be functional is how do you test to make sure that the joints are good after in the end, right? All of the solder joints for ball grid array components are all underneath the chips. So you need the ability to be able to see whether or not they're good. They sell some cameras, some handheld cameras that can look at something at an edge, but they're a little bit finicky and tricky to use when compared to an X-ray inspection system. So X-ray inspection, which is what we're going to demonstrate next, is an inspection metrology tool that allows you to look through the epoxy mold of the chip and see the metallic bonds that are ultimately connecting the solder down to the board. It's useful for a couple of things. Number one, it allows you to look underneath the chip to see the obvious defects, open joints and bridge joints, things that are a little bit more trickier to be able to see, or just something that's purely electronic mechanical functionality. Two, it allows you to see additional types of, depending on the classification, additional types of defects which may be bad, such as what's called head and pillow, which means that the ball is just barely attached down to the actual pad itself, and it's almost like sticking up in kind of some ways would be the easiest way to kind of phrase what this is. Or something that's a little bit more important for folks is voiding. So voids in lead-free solder in particular can be catastrophous in terms of like thermal shock, vibrations, everything like that. It's one of those things where it'll work at first, it'll pass final function test, it'll pass outgoing inspection, and then like 2 or 3 months later, there's going to be a problem, is what there's going to be. Just checking back with the rework section here, we've got now in the third segment of this. So the X-ray inspection tool is a tool that's more or less necessary for being able to look at BGA components with relative quality standards. For some places in the rework industry, they don't have an X-ray tool at all. It's purely functional. It's purely, did I get the graphics chip back down and does the Xbox turn on? Like that's it. That's all that they really care. And even then I'm using it, maybe not an Xbox, but something a little bit more expensive, like a workstation computer or something like that. If you go to like Technology Recovery Group, I know they work on some pretty heavy duty computers and servos and that kind of, or servers and that kind of stuff. And so that might be something that is a little bit more. So, okay, we're entering into the fourth segment. I'm going to cut the vacuum, lift up slightly on the tool, make sure that my nozzles are connected up accordingly here. Yep, looking good. I'm going to get a beep here in the next couple of, in the next little bit of some time, which is, should be, oh, there you go. See? In general, the thickness of the board, I would say, plays a moderate interest towards getting a rework process to happen. It's a moderate factor, is I guess what it means. The thickness of the copper, on the other hand, that's one of those things to where it's like, all right, I am conducting out a lot of heat away from the thing that I am trying to actually get up to the point where it's able to be lifted, which may mean you either have to go to elevated temperatures or extended amounts of time to be able to get that component to get up to where it is. But at the same exact time, support for that board tends to be kind of an important thing, because one of the things that you can probably see on the board that I've got here, which is going to come out right here, is that if I were to place this board onto a table, I've got a little bit of some camber to this board. Not a horrible amount here. I would say like maybe it's about like a millimeter worth or so, but I've got the thing clamped in such a way to where the clamps actually are kind of pushing in on the board just a little bit, while at the same exact time, the heat and everything is causing the board to kind of warp. Now, that's the advantage. That's actually the advantage of these little pins that are right here, because more or less, these pins that hold the board in, hold it flat. They're not putting a lot of extra stress from the sides of the board in order to put it in, because that way you avoid kind of where this camber happens to be with it here, right? Which, speaking of, just to put this underneath the microscope here, it looks like I'm in place. It looks like I've got a good connection to it here, right? So yeah, so I guess to answer your question, we do a lot of our training on 1.2 millimeter thick boards. That training is all about like just like we buy, I guess, like standard board thicknesses, but I would say board thickness is going to play a moderate factor to it. The thickness of the copper, the thickness of like all of the metal that you got on the board, that's going to be a bigger factor in terms of how this overall thing works with it. Welcome to our X-ray inspection system. We use a creative electron inspection system for being able to do this. Actually, let me take you for a quick tour of the machine. So the actual system itself has a stage on the inside where the board is going to go, which I'll put this guy kind of in there right now. There's a little laser scope that's on there that tells me whether or not the thing is there or where the X-ray tube is going to be. Let me take you out of the holder for a second. The X-ray generator is sitting up at the top part of it there, and the collector is sitting down closer to the bottom part of it there. And the board is sitting on a stage which rasters across in X and Y, right? The creative electron system that we use is what I would call a pedagogical system. It's a machine that is better used for doing individual scans of components or boards, and production environment wise, may not be well suited for automated environments, might be the kind of the easiest way to phrase what this is. But overall, for teaching students how to do BGA rework as well as how to do X-ray inspection, this machine was, I think for us, around $90,000 for the total cost for the actual machine. So it's a cute little unit is what it is. All right, so let's turn on our X-ray inspection system here. So I'm going to click the X-ray button onto it right there. Let's get you zoomed in to where you can see what I'm looking at here. Hang on one second here. Let's zoom you in. Okay. And there is the X-ray inspection of our BGA Rework. Let's see here. Just want to make sure that everything's all on screen as close as I can get it there. Okay. All right. So my controls for the stage are actually located in the bottom right. So I'm going to, and I never get this right at first. It's kind of got little backwards controls to it. And so these are the balls around where the chip is actually connected up to this. Now, just to show you what this looks like, let me go a fair distance. Let me move this up, I think. And what you are looking at here in this window are actually the pads for these. What you're looking at right here, these are the pads for the board. There's actually two spaces where these BGA components can actually go. What you're looking at right now are the pads. Now I'm going to go back to our BGA Rework chip. So X-ray inspection allows us to see kind of what's on the inside of the chip. So what you see kind of in the center portion of it here, this is the internal die where the memory is. That the die has wire bonds that connect to the inside parts of what's on the inside of the package. And then going around the outside edges are the actual interposer connections, which connect down to where the BGA solder joints are, which is also connected down to the board, right? And so one of the goals that we want to look at with the X-ray system is, can we see, are there any disconnections between the balls and the actual pads themselves? So what we're going to do is kind of change some of the settings around a little bit in terms of what it is that we're looking at here. So what I'm doing is I am making darker things or lighter things appear just a little bit darker to it here. And we're going to turn up our exposure just a little bit here, and we should see a couple of things begin to pop up. All right. Overall, I don't see any obvious defects. So these are what the balls actually look like on the board here. When compared to, oops, did we go past the pads? I may have gone past the pads here. Where are they? Where are my pads? What happened to my pads here? They might still be there. Ryan says, where are they? My exposure is kind of limiting what I can actually see to it here. Oh, no, they're not there. Where did I go? Okay, here we go. I got to move up in the other direction. There's where my pads are. That's my neighboring pads for the spot that's next to it there. So I'm going to make these pads actually just a little bit darker, which makes them show up just a little bit more. Now, if I don't see any obvious disconnections, I don't see any of them kind of bridged together or anything like that, that, in my opinion, is a good sign that this has been soldered up correctly together. But we know that this doesn't always happen to it, right? Ryan, do we have a board that has some defects on it? This one's got a few. You got one that might have a few to it on there. No, in that corner there. Oh, yes, yes. All right, so let's turn off our X-ray system. Let's turn off our X-ray. We're going to kind of pull out a little bit here. X-ray system is turned off. Open up the door. I'm going to move a new BGA chip into there. There we go. Turn back the X-ray system on again. All right. Let's show you what a couple of defects look like in terms of when solder or BGA rework has not been done correctly, because in many of the cases, that's something that is a little bit more important for the X-ray operator to be able to identify. All right, so now let's move up. Okay, good example. Good find there, Ryan. Okay, so a couple of things to see. Let me put these kind of in the center. Let me adjust my jogging so that I am not moving around too quickly. Oh my God, look at how terrible that looks. Okay, so here we've got a few problems here. Let me, whoop, I'm moving the wrong way. I do that all the time on here. Okay, so you see what this little kind of noodle thing looks like? Noodle thing, what these two guys right there, how there's some darkened in areas that are connected up to this. Because X-ray, this is very similar to how an X-ray system works for, like, you know, you trying to figure out if your bone is broken, except it's inverse. Metal is going to look dark. Ceramic looks kind of like a lightish gray color, and then insulator material just basically looks bright white with it. So for the most part, so you can see there's a few things wrong. That's a bridge. That right there is a straight out problem. So that's a bridge underneath the BGA component. You see how these connections look like they're not circular? They're more or less ovular, might be the right, or oval-like in its shape. This is your sign that you've got a misalignment issue somewhere on the BGA, and it's very apparent right over here. These pads that are on the on this part of particular side to it right here, these two pads, or that ball and that pad, are completely off center from each other. They are not connected at all on this particular component. Another thing that can occur in BGA rework, which is very, very common, is voiding. And I'm going to focus kind of in this little area right over here. I don't know if you can see this, folks, but there are there are some dots that are, let me try and zoom in here, see if we can get a closer look at what this looks like here. All right, let me increase my exposure up just a little bit and increase this guy there and make this look a little bit better here. Okay, so folks, do you see, I don't know if you can see this here, but in each one of these little dots, there are little tiny white circles that are on the inside of those guys, these little white circles. This comes from one of two common problems with BGA Rework. Number one, a reflow or a BGA Rework temperature profile that is either heating up too quickly or cooling down too quickly. One of those two, right? These are solder voids. And generally speaking, for A610, if any one of these joints has 25% or more voiding, it's considered to be defective at that point. It's considered to be a not so good of a joint, right? And so these voids can occur from improper BGA rework profiles, is where that can happen with, right? Which, generally speaking, this whole board itself is just not done. This whole chip itself is just not done very well in terms of how this overall looks with this. So, but yeah, you need an X-ray tool. You need an X-ray tool to be able to find what some of these components look like afterwards, because your only other hope after that, is to test it out and see if it actually tests correctly to there, provides a final function test with it to there. So just to recap with what we've done here. So talked about BGA rework and basically the overall process. The overall process for doing BGA rework involves, if you've got a board that has a defective component on it, is you need to remove the component using the BGA rework process, which is apply flux, heat it up, use a vacuum pickup tip to lift the part off, right? Then take it over to a cleaning station to where the pads of the component can, or the pads of the printed circuit board can be kind of wiped clean, tinned, flattened, if you will, as much of a smooth overall thickness as possible. While at the same exact time, if you need to redo the chip, it's one of those you're gonna have to reball the chip. It's similar process to that, but much more of a difficult process to be able to do. Which hopefully, Carrie, on the next one, invite me over here again. We'll do a reball video at some point. That'll be kind of a fun one to do. I kind of wasn't prepared with all my stuff to be able to do it just as of yet. So that's my thing to do for one of the next ones there, if people are interested in that. Then step 3 is to put the new chip or reball chip back onto the rework system, align it, spend some time aligning it, making sure it's in the correct polarity and everything like that, and then reattach it down to the board in a similar process to doing a rework. And then finally, X-ray inspect it afterwards to make sure that the joints are all there, that there's no opens, there's no shorts and bridges between the pins, no voids or anything like that. And overall, that the alignment is satisfactory to where all of the joints more or less look circular in how they look.